All right. Hi, as Phil mentioned, I'm Mayank Saxena, Senior Director of Engineering at MSL Samsung. And all right, in this talk, we are presenting high performance object storage, which enables the fast emerging use case and need of high performing real-time analytics over large scale object storage. HPOS solution, what we have done in MSL Samsung, we have mindfully architected this whole use case, which utilizes the emerging concept of S3 Select, where data of interest, there is specific columns or chunks within them for a particular query are processed versus the traditional way of transferring the complete data set to CPU. As you can see on the top right, various ML applications needing to serve real-time analytics utilizing S3 and now have additional interface of S3 Select in addition to standard other S3 functions, right? And for this, we have utilized computational SSD, basically enabling application to have data of interest chunked and stored in computational storage, and then do the compute new to the storage. Major benefits, as you can see on the left of the slide, is faster queries, since the compute is happening near to storage, lesser network traffic, and reduced TCO due to the reduced CPU and network traffic. And we have done some benchmarking, which I will walk you guys in a short while. But I'll pause here just on the high level concept if anyone has any question on this slide. Right. So quickly jumping to the benchmarking itself, the benchmarking setup, and then I'll explain how exactly the whole stack looks like. What we have done here is taken a standard S3 kind of deployment. So on the top, you see the AWS baseline, which has on the left, you have the standard client, S3 client. On the right, you have a standard AWS S3. And on the bottom, we have Samsung's HPOS setup utilizing the computational storage, and pretty much the same thing. On the left, same client, which is querying the AWS S3. Now on the bottom, it's querying the HPOS S3. And on the right, bottom right box, what you see is like 3 or 4 components. One is, well, AWS S3 is a black box, right? So once you query the S3, you get the result back. On the HPOS side of things, I can tell you a little bit more because that's something what we control. So HPOS server is a host which runs the query. An object store in this case is a computational SSD, and which has this accelerator running the S3 or scan IP. And we ran the standard customers sample data set with a standard query, and then I'll walk you guys through the actual demo as well. Let me jump to the next slide, and I'll pause for the questions again. So going back to my previous slide, I'm going to walk you through the HPOS server stack here on the green, on the bottom left box, bottom right box. So think of it as a layered architecture where on top, as you can see, there's the AWS client, or I should say S3 client. And then there's the HPOS software, which majorly consists of 2 main things. One is the host, where we have utilized our open source software called disaggregated storage solution, open source by Samsung, and that uses the KV Select store. So host runs that software, and the target, we have the KV target, which has the orchestration layer talking to the computational SSDs. And at the bottom, you have computational SSDs supporting P2P, and with the standard, the normal data path goes through NVMe, and then for the querying and getting the data back, we use this. In this setup, we have used Xilinx XRT stack. Let me get rid of this. Any question before I move forward? All right, so just for everyone's interest here, I'm going to run this demo. It says demo video, and then I'll walk you through while it runs as well. So as you can see on the screen, on the top left, you have AWS, where we run the query to the AWS S3. On the left bottom side of things, you have HPOS S3, and on the right big screen, it's a host CPU, which will tell us how much compute we are actually utilizing from the normal CPU using HPOS. It's kind of a drag race. So we issued the query for AWS, and now for HPOS. HPOS, the result is already back, as you can see in the red highlighted box, of throughput as well as the latency. On the AWS S3, the query is still running, and it should come back in a while. And on the right, you see the CPU utilization on the host, which runs the query for HPOS. Since nothing is so fancy, I'm gonna fast forward to probably last few seconds, because we're gonna stare at AWS screen while it comes back. And it did come back now. And as you can see, the throughput and the elapsed time for the same data set and for the same query. And we'll have this result analyzed in the next slide. So what you saw is basically that's what we have plotted here. Standard S3 versus S3 accelerated using computation SSDs. We get a really huge increase in the throughput, as well as a huge decrease in the latency, while the CPU utilization is almost negligible at 0.12%. To dig this further, that whether the CPU utilization makes sense, we ran one SSD-based, one computational SSD-based experiments as well for the same S3 Select across multiple servers. And we do see, and this is the numbers we have measured through Dell's IRAC standard server power monitoring system, that during the query, we do save compute on the host when you don't use the computational SSD, the computational aspect of the computational SSD versus the computational SSD. And we do see a per SSD at least 2% of power usage saving. Our next step is always to get the large scale measurement to showcase the TCO and the green aspect of the computational SSD, along with the throughput and the latency improvements we get in comparison to the current standard market solution. All right, and with that, that was my pretty short talk. I will be happy to take any questions at this point.
Cool, thank you, Mayank. I have no questions teed up, but there will be time over the course of the next 50 or so minutes for people to ask questions as they listen to the other demonstrations going on. Thank you very much.
Sure, thank you. Let me stop sharing.